Good morning to the next lecture. Today we are going to see Unit 3, that is stability of dams. So in this we are going to first see about dam and how it is what are all the forces acting upon, what are its types, and how to find out the resultant force. And then lecture 2 will be problem related to uh, the forces applied on the dams and what are all the stresses which is going to be acting on it. Then in the lecture 3 we are going to see how it is going to be stable, that is stability of dams, conditions for stability of dams. So let's enter into the lecture. So dam is a structure which retains the water on one side, and it will be used to store store the rainwaters. So what are the types of dams? There may be many types of dams. Here the classifications are: rectangular dam, this is based on its shape, that is cross section shape. First one is rectangle, second one is trapezoidal. You can see that water face vertical, that is on the side of the water. If the dam is horizontal or vertical, then it is called as vertically faced. Then another one is a inclined face. Let's see one by one. So first thing is rectangular face. You can see that the trapezoidal, or compared to the rectangular, it is economical and easier to construct. Hence in these days trapezoidal are mostly constructed. Now let's see with the rectangular dams. So what are all the forces? First we can see the first you will see what are all the diagram. So how a rectangular dam will be. So you can see that this is the water side and this is free side. So this is a rectangular cross section shaped dam. So it has a width of b. So it has a width of b and height of h. In this you can see that clearly the center of gravity of this rectangular shape will be at this middle g point, middle g point. Then so you can see the water standing at a height of small h. So the total hydrostatic pressure acting on the water over the dam will be equal to force F, the hydrostatic force F. So this is the first force acting on the dam. Then about the CG point, the weight of the total dam will be acting at the downward direction. So this will be horizontal force and this will be W will be vertical force. So resultant of these two forces, that is horizontal and vertical, will give you the resultant force. So this will give you the resultant force. Now the step is to find out this x distance, that is the force, resultant force acting point is called as that is x. We have to find that, or it is called as eccentricity. Then next one is what are all the stresses acting on the dam, that is at this corner and at this corner, what are all the stresses. These are going to be in derivation. Now let's start with the derivation. So what are all the things we have seen? The height of the water is small h. The force acting due to the water is F. The weight of the dam per unit length is W. Height of the dam is capital H. Width of the dam is small b, and weight density of the dam is W naught. So first, the force of water. The force of water. This is the formula, which is nothing but W A into H bar. W A into H bar. Here W. So this derivation can be seen in the fluid mechanics book. I also will state how it happens. W is nothing but the weight density of the water. W is the weight density of the water. and A is called as area of A is nothing but the area of contact on the dam. Then H bar is nothing but the CG point at which the force acts. The CG point at which the force acts. So it will be nothing but, with this diagram I will show you, W is weight density of the water, H into 1. Here the area of contact is this perpendicular, that is perpendicular to this image. The distance of perpendicular to the image is nothing but length. So H into 1. H is the height of the water, and 1 is the length of the wall. Length is, we are considering length as 1 meter. And then H bar is the CG point of the H bar is the CG point of the wall, that is G. So G is placed nearly H by 2, so it will be, which will be equal to W into H square by 2. This is the total force acting on the dam. Then W, so we have found out F, then we have to find out W. What is the force W? So W is nothing but weight of the dam, weight density of the dam into volume of the dam. Weight density of the dam into volume of the dam. So weight density is W naught. Volume is nothing but area into length. So area of the dam is B into H. That is capital H into B. So this is the area of cross section into the perpendicular distance is taken as 1 meter. So that is length of the dam is 1 meter. So B into H into W naught. This is going to be W. So these are the two forces, W vertically downwards and F horizontal. So now you have to find out the resultant force. Resultant force is nothing but square root of F square plus W square, which is nothing but, you can see that this is vertical and this is horizontal. So inclined will be the hypotenuse. So R is equal to square root of F square plus W square. So what will be the angle? That is the inclined angle. So the inclined angle of this R. How to find that? We can see that is tan theta is equal to BD by OB. You can see here it is BD by OD, that is hypotenuse. That is nothing but tan theta, sorry, BD divided by OD, that is adjacent side by opposite side by adjacent side. So with this we have to find out the theta, which is nothing but BD is nothing but the horizontal force, that is capital F, and OB will be vertical force, that is W. So it will be equal to F by W. Then horizontal distance between the line of action. So next we are going to find out this X distance, that is where the resultant is going to act, that is X distance. For that, so the resultant, so X is nothing but the distance MN. So here the distance X is obtained from similar triangles of OBD and ONM. So we can see the triangle OBD and ONM. So this big triangle and also this small triangle, these two are similar triangles. With this, the ratio is NM by ON is equal to BD by OB. You can see that NM, that is, this is the horizontal distance NM, and then ON is the vertical distance, that is horizontal distance divided by vertical distance will be equal to BD divided by OB. You can see that this is OB and this is BD and this is NM and this is ON. You can see the vertical and the vertical divided by horizontal, that is NM by ON Nm by On will be equal to BD by OB. So here Nm is nothing but the x distance. Nm is nothing but x, and On is the distance, that is h by 3. The force, that is the hydrostatic force, will act always one third of the height from the bottom. You can remember this, always it will be h by 3 distance from the bottom. So On is h by 3. Here BD by OB is equal to F by W. With this, x is equal to F by W into h by 3. So this is the total x distance we are going to find out. So these are the steps in the derivation of the rectangular dam. Thank you.